To test a population proportion, that's when we're looking to say, I had a sample and 40% of the voters were going to be voting Republican, so I'm going to propose that the population that will vote also 40% Republican, of course with some measure of spread. If we want to test those type of things, we use a z-distribution. First we have to require that the sample is large enough that n times p is greater than or equal to 5 and n times q is greater than or equal to 5. Remember, q is simply 1 minus p. P is the probability of success in a binomial experiment. The test statistic, the thing that helps us draw the conclusion for the hypothesis test, is a z-test statistic. We cook it up by doing p hat minus p divided by the square root of p times 1 minus p divided by n. All that stuff in the denominator is under the radical. I hope you recognize these symbols. P hat is the sample proportion. What we saw from the sample for a percentage of success there. P is the value that we assume to be true in the null hypothesis. N, of course, is the sample size. To run these tests in the calculator in the TI-83 or 84, it's in the test menu, so click the Stat button, scroll over to Tests, and we've seen the z-test, we've seen the t-test. We want to scroll down to the one proportion z-test. It's important that you find the proportion part of the z-test, because then it will prompt you for the correct information to test proportions and not means when the standard deviation of the population is known. Remember, with this test statistic, the steps are exactly the same to create any hypothesis test. First, we need the null and alternative hypothesis along with the level of significance. Then we must determine the distribution. The question is always t or z. Which distribution do we have? If it is a proportion, just like in confidence intervals, the proportions are always z. Once we know the distribution, we can calculate the test statistic. Once we have the test statistic, we can find the p-value of said test statistic, and then finally make a decision. Reject the null hypothesis, fail to reject, and conclude if we have sufficient information from the sample to support or reject the null hypothesis. Here's a basic sample. Random sample of 60 binomial trials resulted in 18 successes. So 60 would be the sample size. Number of successes is 18. We typically use X. The textbook we use in this class uses R, but the number, no matter what letter you use, is 18. The claim is that the number of proportions, or the proportion of success, is greater than 18% with a level of significance of 0.01. Can a normal distribution be used for the p-hat distribution? This p-hat, the sample proportion. Let's test it out. NP is sample size 60 times the proportion that we're testing, 0.18. That is 10.8, which is in fact greater than or equal to 5. And NQ is sample size 60 times Q, 1 minus 0.18. That is 49.2, also greater than or equal to 5. So yes, we can in fact use the z-distribution, the normal z-distribution, to make this test. Moving forward from here, we'll state the null hypothesis, that the proportion is equal to 18%, or 0.18. Remember, the null hypothesis always contains the equal to sign. The alternative hypothesis is the part where we use what we're testing. We would like to know if the proportion is really greater than 18% in the alternative hypothesis. To cook up p-hat, Remember, this is x over n, or in terms of the textbook notation, r over n. That is 18 successes in a total of 60 trials for a p-hat of 0.3. That means 30% of the sample exhibited this characteristic. Then, because we have t-hat, we can make the test statistic z, which is p-hat 0.3 minus p, the thing we assume to be true, 0.18, divided by the square root of p, 0.18, times 1 minus p, divided by the sample size. That cooks up to be 2.419, or about 2.42. Remember, in the calculator here, use 2 parentheses for the numerator, and then the radical kind of does the trick of keeping everything in the denominator where it goes. You only need a little multiply sign here, and then make the division, and you'll be in good shape. To find the p-value of the test statistic, remember what's going on. This is a normally distributed test statistic with a value of 2.42. Our hypothesis test said we were looking what the probability was of being greater than this value, so the p-value will be to the right of the test statistic. The p-value here is the probability of being greater than 2.42. Probability that z is greater than 2.42. We can find this in the table by looking up negative 2.42, since the table gives us left-handed values. Let's give that a look. So negative 2.42 has an area to the left of 0.0078. So with the p-value of 0.0078 and a level of significance alpha of 0.01, we can see that p is in fact low. P is less than alpha, therefore we have sufficient information to reject the null hypothesis as the decision from the hypothesis test. If p is low, reject the HO, and that's what we've done. The sample information supported the information from the alternative hypothesis, not the information presented in the null hypothesis.